So first of all, I am going to discuss about bibliometric databases and indices. We have three major databases of bibliometric databases. So Web of Science, Corpus, and Google Scholar. And what is indexation? Index are the database of scientific journals having good track record of maintaining the ethics and quality in terms of publication. So if you are publishing a journal, that journal would be should be listed in the indexes. Otherwise, there is no use, and you will not get any academic accreditation when you publish a paper. That paper is not that journal is not listed in any of the indices. So indexing journals considered to be higher quality in comparison to any non-indexed journal. So that's the main thing. So that these indexes are very important nowadays. If a journal is not indexed, that journal is treated as not treated as a quality one. So various institutions, universities, they are preferring indexed journals only. So indexing of journals provides better visibility of the journal with a wider users. So being visible and accessible to larger people will cause better quality papers. It's similar like, finance people, all finance people, you might have experience with the National Stock Exchange and Bombay Stock Exchange. These are two indexes, two stock exchanges, and National Stock Exchange is a quality stock exchange as compared to Bombay Stock Exchange. So, National Stock Exchange listed companies are more quality-wise better than the companies listed in Bombay Stock Exchange. So there is a listing requirement of National Stock Exchange is so strong, so that a small company cannot afford to list in National Stock Exchange, but it can be easily to list Bombay Stock Exchange. That's the difference between the Scopus and Web of Science. So Web of Science is a much quality index as compared to Scopus. Scopus is like an ocean. All the journals, many of the journals has listed in Scopus index. So I will tell the details in the later part of my slides. Being visible and accessible to larger people will cause better quality papers. So the indexation is very important. So nowadays people are taking care of the indexation. So importance of bibliometric databases. Bibliometric databases are the main sources of publication metadata and citation metrics. So Web of Science, Google Scholar, and Scopus are the three bibliometric databases generally accepted as the most comprehensive data sources for various purposes. So out of this, Google Scholar is free, and you can register Google Scholar and you can add your publications in the Google Scholar. But the Web of Science and the Scopus, it is a paid platform. So your institute or university has to subscribe for getting the databases. So these databases are subscription based. I already explained. Both Web of Science and Scopus are commercial and subscription based products. It has got worldwide recognition. Use of these databases has to pay high price, which makes rarely affordable for an institution to subscribe to both of them. If your institute is not subscribed to this database, you can get it downloaded from the neighbor institutes. They have subscription of these databases. But the subscription is costly. A small institute cannot afford for the subscription of these databases. I will explain. Web of Science has itself, 6 or 7 indices. Inside that, small indices. So we can also subscribe. One out of Web of Science, we can subscribe. We need only Science Citation Index. We can subscribe Science Citation Index. We need only social science. We can subscribe social science. So institutions are often forced to choose between these data sources. So nowadays institutions are very interested to subscribe these databases, because these databases are very important for the bibliometric, literature review part of the scholars. This is very important. So this is so helpful for the literature review part. So sources of information. Bibliographic databases are the main data providers for major global universities ranking process. So you will get data from the Web of Science or Corpus regarding the university ranking in terms of the publications. So you will get data like which institute provides funding to what kind of journals, which author getting funding from which institute. These details you will get it from the databases. It provides details such as which university has more number of papers in a particular discipline. So whether it is Oxford, Cambridge, MIT, which university has more number of papers in a particular discipline. So if you are taking a discipline, you need to identify, you essentially request to identify which university is working more with the discipline. Then we can follow that university and we can follow that authors to get more details. Okay, if you are a serious researcher, you definitely must follow the serious researchers in terms of the discipline you have chosen. So which publisher, either Elsevier or Taylor and Francis or Springer, has more papers in particular discipline? So users of databases, it has daily users such as librarians, students, lecturers, and researchers who can exploit the databases for academic purposes. So there is a new stream which was developed, I think 5 or 6 years back, but is now very prominent because of the emergence of some softwares like Osphere, Pagec, RStudio, Jeffy. These softwares are very helpful for finding out the keyword co-occurrences and other analytics, etc. These trends, these analytics trends will get you. You can be able to predict future works also. So that way, this is very helpful. So now these data sources provide detailed information of publications, citation data, bibliometric indicators, journals, authors, institutions, along with the analysis tools. So bibliometric analysis papers is the new stream developed from the databases. So I would like to state that you might have experienced now each and every journal will be interested to publish a bibliometric paper based on the already published papers over a period of time. For example, 25 years, 25 years or 30 years. So, but you should be careful about while you preparing a paper and you are targeting a journal and you are going to prepare a journal on 25 years work on a particular journal. For example, you are interesting to prepare a paper and submit to a Springer journal. That journal has experience, 25 to 30 years experience. So you should be careful when you prepare a paper based on the 24 years work published in that journal. And if you are preparing the paper based on the 24 years work, that paper should be accepted by that journal. Otherwise, that paper will not be much used because your work fully based on the 24 years published papers of that journal. So while doing so, that you should be careful. Otherwise, we can use some kind of thematic topic and with the help of some keywords, and we can submit to the journal related with the keywords. Okay, both ways we can do and make papers. Okay, so I will answer your questions after my presentation. Please text questions in the chat box. I will answer it. So provides very vital information. Databases are useful to search for most relevant literature and select journals for publishing or subscribing. Possible to track personal career of particular author, identify collaboration or funding opportunities. So that's very important. If you are interested in a particular discipline, you are expecting or you are choosing or you are interesting for a funding opportunity, and you can search it, that paper, you can search it with the help of keywords of that your discipline, and find that which of the institutions in the world providing funding to that discipline. So you will get data from the Web of Science as well as Corpus. I will show you how to collect these details after this presentation. Then authors affiliations, recent trends of topic evaluation, funding opportunities of topic, etc. So these information you will get, and this would be great helpful for your paper preparation. So these are the softwares for bibliometric analysis: Pager, CourseViewer, RStudio, Publish or Perish, with Big Excel, Jeffy. These are the main softwares which are used for the bibliometric analysis. And also Mendeley we are using for referencing. Mendeley is also, we can connect Mendeley with this kind of softwares, because we can download RIS format file from the Web of Science as well as Corpus, and we can insert it to Mendeley, and we will get easily cite these papers. So Web of Science, first of all, I will detail the Web of Science. Web of Science, formerly known as the Web of Knowledge, was the first bibliometric database, was founded by Eugene Gatfield in 1960 as the Institute for Scientific Information. So the old name of Web of Science was Institute for Scientific Information. During the acquisition by Thomson Reuters company in 1992, received its current name Web of Science, and it is abbreviated as WOS. In 2016, Web of Science was acquired by Clarivate Analytics. Now it is owned by Clarivate Analytics. So Web of Science was the only source of bibliometric data for more than 40 years. Until 2004, the Scopus was launched by Elsevier. So 2004 only Scopus was emerged, and Scopus was launched by the Elsevier. So these are the indices in Web of Science: Science Citation Index expanded, Social Science Citation Index, Arts and Humanities Citation Index, Conference Proceedings Citation Index, Book Citation Index, Emerging Sources Citation Index. So you can subscribe all these indexes. Also, you can subscribe individually. So subscription rate will be lower if you subscribe. If a social science discipline person, if a person from commerce and management, that person will be helpful. I mean, social science citation index and arts humanities citation index helpful for the commerce and management person. Okay. So some of the university, our university purchased the entire Web of Science index. So it consists of all these indexes. So Scopus is similar multidisciplinary and selective database. So Scopus is similar multidisciplinary and selective database, which was launched by Elsevier in 2004. The main difference from Web of Science is that all Scopus content is accessible with a single subscription without possible modulations. So Scopus, you will get Scopus in a single subscription. So over the years, Corpus has earned its equal place as the comprehensive bibliographic data source, and it has proven itself to be reliable and in some aspects even better than Web of Science. Some of the people are mostly interested in Scopus. So, you know, I already explained Scopus is like an ocean of papers. So I would say all the quality journals are listed in Scopus, but the Web of Science, you will not find all the journals. So if you search if you search a journal, major journals are indexed in Scopus. But the Web of Science, it's like a national stock exchange. All quality journals only listed in Web of Science. So Google Scholar also made its appearance in 2004. Google Scholar offers considerably wider and deeper overall content coverage by disciplines, document type, countries, and languages. Google Scholar is less reliable as the bibliographic data source as compared to the subscription-based database. You know, Google Scholar is free, so that there's a problem and manipulations, and we cannot depend on the Google Scholar. If you search with a keyword, you will get journals all from it is not indexed, so that if you cite papers when you search keywords from the Google Scholar, that paper will not be accepted by the standard journal. If you are preparing papers, you have to cite, you should cite papers from published by the standard journals only. If you cite papers of low quality journals, that citation will not be approved or accepted by the journal journal and authors who are reviewing papers. So that's very important point. If you cite papers, if you cite authors, that authors publish papers in a very good reputed journals. So limitations of Google Scholar: lack of transparency, stability, precision, and control. Unavailability of its data export. By simple experiment, it was also shown that Google Scholar can easily be manipulated using falsified data. You can see that Google Scholar all fake manuscripts, all cooked up manuscripts, all indexed in Google Scholar. So you can download it and you can see that that papers did not have proper quality. So Google Scholar is not accurate as much as compared to the paid platforms such as Corpus and Science. So coverage of research in this indices: the fact that Scopus provides wider overall coverage as compared to WOS, Web of Science. The content indexed in WOS and Scopus was also shown to be highly overlapping. Scopus is like an ocean, and Scopus indexing a greater number of unique sources is not covered by WOS. The extent of content overlap between WOS and Scopus was determined to be varying greatly across disciplines. And you should also careful if you are a university, subscribing both platforms is unnecessary. So one of the platform would be good, if Scopus or Web of Science. Otherwise, if you subscribe both platforms, some kind of duplication. The journals indexed in Scopus is also indexed in Web of Science. So if you collect data from both Scopus and Web of Science, it will not be useful much, because some kind of majority data would be duplicated, because the same journal is indexed in Web of Science and Scopus, so duplication is more. So coverage of citation of data. The coverage of citation of data is extremely important for the analysis focused on quality and impact. So you see that Web of Science is the old journal, so you will get data from 1980s. If you search Economic and Political Weekly, that's the most prominent journal from India. So you will get data from Economic Political Weekly from 1980s to 2010. You will get data from Web of Science. Okay, so all the papers are indexed in Web of Science. So you can do an analytics based on the EPW papers. So amount of citations that were retrieved by the databases firstly depend on coverage width. Citations count from year to year is possible. There are journal prestige indicators. A citation from the high quality journal is worth more than citation from the obscure journal. I already explained. A citation from the high quality journal is worth more than citation from the obscure journal. So when you cite, please keep in mind your citation and your cited authors publish papers in good journals. So some of the scholars, I have noticed that they cite authors publish papers in low quality or without indexed journals, UGC care listed and all. It's not that journals are not indexed in Web of Science and Scopus, and the publisher is also not good. Sometimes that will be a problem for when the extension of research happening. If the candidate publish thesis in some other journals after the open defense, that will create problem for him. The databases as indicators make a distinction between the journal popularity and prestige. It provides details of H-index. H-index is an index for calculation of productivity of an author. So we will get the H-indexes of most prominent authors of your discipline. If you are doing research in nudging, you will get most popular authors and you will get H-index of these authors. So citation counts. Time frame of covered citations in Scopus is shorter than WOS. Scopus was shown to provide higher citation counts than WOS. Of course, Scopus is an ocean, So many journals are listed in Corpus. So several studies have reported lower citation counts in Corpus when compared to WOS. So I'm concluding this part. During the last decade, there was a significant growth of available bibliographic data sources and metrics. Web of Science and Scopus still remain the most comprehensive sources of publication metadata. Therefore, they serve as the main major tools for a variety of tasks, from journal and literature selection or personal career tracking to larger scale bibliometric analysis and research evaluation practices in all possible levels. However, these databases are subscription based and expensive data sources. Institutions often have to choose between them. Institutions has a demarcation or a criteria whether they need Scopus or Web of Science. I'm going to show how to extract data from the Web of Science next.